which kind of amplified the signal a little bit, and then through the PLC it could read, over a different sample rate, it could read a weight loss actually being inputted. We did look at trying to buy a load cell and an amplifier and creating our own scale, but that was $3,500 and our budget was $1,500. So we were not able to do that. Some improvements might be able to be made with that. We also tried to build an amplifier with Professor Turkman. There was a lot of noise, and that did not work at all, so we ditched that and just ended up using that indicator, which brings us to the ASCII code. That was kind of a hard thing to comprehend because we'd have to decipher an ASCII code and make it into a real data pretty much that our PLC could use. It took a long time to kind of figure out how to do that, but it ended up working.
So here's kind of the part flow and how the whole system works. So you have the pellets coming into the hopper from the top side, and which you have the load cell, which is the red block on the bottom, and that reads the weight of the hopper and the pellets and everything all together, and sends that information to the control panel, which converts it and sends a voltage to the motor, which changes the auger speed, which will change the flow rate. And as it comes out, you want it to be 0.6 grams per second flow rate, which will then go to the extruder. And then it takes about 8 minutes from once the pellets enter the extruder to exit the extruder. So you won't really see much of a difference of it. It's more of a kind of on a micro level that you start seeing things.
So with our program, the basic logic behind it is the user inputs desired mass flow rate, that enters in on the left. What you see here on the right is us actually taking reading from our scale. We use that to calculate the mass flow rate. We compare that to the desired value. Then based on our controller, it'll either up or down the voltage just to hit the ideal flow rate we want. Here you can see our HMI. Pretty simple to work it. You input a flow rate, you hit push to start, and if you want to run it the old way, so you maintain the full functionality of the feeder as it was before, you can input a manual speed, press the go to volumetric speed, and push to start, it runs the same as it ever did. And we did our testing after we got it roughly half put together. The results were nearly as good as we hoped. Our gravimetric feeder was actually less steady of a flow rate than the one we tried to replace. The big issue we had was really, we always oscillated about the mass flow rate we wanted. We never really hit it. So we're going up and down constantly, rather than being where we want to be.
So moving forward in the future, one of the things that we could do to improve on our project is to add a motor encoder. This would mount to the back of the motor on the feeder, and it would track the RPMs of the auger. Right now, basically what we're doing is inputting a voltage to that motor and assuming that it's running at a consistent speed, but without that encoder, we really don't know. Another thing that you saw in the figures before was the peaks and valleys in our data. So the valleys were what we believe to be false data. We would get a 0 reading from the scale, and that was probably because of the ASCII data problems reading that. So we'd get that 0 reading, and then all of a sudden the system would panic and really ramp up the motor speed to try to make up for that. So that was where we would get those peaks. So we believe if we could get rid of these peaks and valleys, we could really make this feeder a lot more consistent than what we were seeing. And then, like we said before, when we were in our initial design, we considered doing 4 load cells and 4 amplifiers. So in the future, we are leaning towards going this direction now that we can actually justify that cost. So what we would do is basically completely ditch the scale that the feeder was mounted on. We'd make our own chassis, put our load cells in there, and that would give us a much better resolution. Right now we're using a 100 kilogram load cell, and our feeder completely full is only about 50 kilograms. So all we would do is say get 4 load cells that are 15 kilograms, and that would increase our resolution and give us more than enough capacity to handle the full heater. And going the route of the load cells would also allow us to get away from reading the ASCII data that we're getting out of the head unit on the scale, which proved to be very problematic throughout this project. So as far as safety, with any engineering, safety is obviously a big concern, and we had some concerns ourselves, so we implemented a few features to make this product as safe as we could. One of the big things that we had was a main power disconnect on the outside of our electrical box.